In this video, we're going to perform a man-in-the-middle attack with ettercap, and the attack we're going to use is ARP spoofing. But before we do the attack, what is ARP? ARP stands for Address Resolution Protocol. ARP translates IP addresses to MAC addresses so devices can properly communicate and send data on a local area network. All operating systems in an Internet Protocol version 4, IPv4, Ethernet network keep an ARP cache. That's a listing of those IP address to MAC address translations. Every time a host requests a MAC address in order to send a packet to another host on the local area network, it checks its ARP cache to see if that IP to MAC address translation already exists. If it does, then a new ARP request is unnecessary. If the translation does not already exist, then the request for network addresses is sent and ARP is performed. ARP broadcasts a request packet to all machines on the LAN and asks if any of the machines are using a particular IP address. When a machine recognizes the IP address as its own, it sends a reply, so then ARP can update the cache for future reference and proceed with the communications. While ARP is fast and efficient, hackers can manipulate this system. During an ARP spoofing or ARP poisoning attack, a hacker crafts fake ARP messages that link a malignant MAC address to a legitimate LAN IP address. Data heading to the victim's device will go to the hacker's device instead. This approach can lead to what we call a man-in-the-middle attack. So for example, if computer named client asks for the MAC address of the computer with IP address 172.16.1.100, well, if it's not in its cache, it's going to send that ARP broadcast out. The Kali Linux box here in this case could, by using some easily available tools, poison the ARP cache by fraudulently responding to that ARP request. So, what do you think? Should we do this? Of course, that's why we're here. Let's do this, but let's do it in a controlled environment for educational purposes only. Remember to practice ethical hacking. Don't do this on networks that you do not own and control. Okay, so let's take a look at the lab controlled environment that we have set up here. We have a host computer that's going to act as a file server. That host has a MAC address that ends 8B5BBA. We have a client that we're going to use to copy files to that host machine. That client, that MAC address ends 209859. Now, we're going to have a Kali Linux who's going to perform a ARP spoofing or poisoning attack. And it's going to target both the host and client computer so that all traffic between these two machines will go through the Kali Linux box. All right, let's take a look at our virtual machine. So we have a client machine here. It's a Windows 10 machine, and I'm going to ping the computer named host. And I'm getting replies back. I'm going to go ahead and now go to my host machine, and I'm going to ping the machine named client. And I'm getting my replies back. Remember, we said that each of these has its own ARP cache. Well, we can view that ARP cache in Windows by doing the command ARP -A. The IP address of the client computer is 172.16.1.5, and remember, its MAC address ended in 209859. So I have a legitimate MAC address, IP address translation in the ARP table. Let's go to the client computer, issue that same ARP -A command, and here The IP address of the host computer is 172.16.1.100, and if you remember, its MAC address ended 8B 5B BA. So it has also a legitimate address. So everything here is working on the up and up as it should. Now, ARP requests don't go beyond a router. They stay on a local area network. So for this attack to happen, we have to have the attacking machine on the same network. So we happen to have on this network our Kali Linux machine. Okay, so we're going to log into the Kali Linux machine, and we're going to use a tool called ettercap. So ettercap is underneath sniffing and spoofing, and we're going to launch the graphical interface for this, and I'm putting in my sudo password because it wants to run as the root user. Okay, so it's going to ask us to set up it. I'm not going to turn on sniffing at startup. We don't need that for this application, and I'm going to leave it at ether 0. It's going to be on this local area network using the default interface. I'll accept those settings. Now, in order for this attack to work, ettercap has the ability to scan the network for hosts. There's only 3 hosts on this network, so it shouldn't take us too long. I'm going to go ahead and scan the network. And you can see down here in the window, it added those 2 additional hosts. We're going to go ahead and list out those hosts. Now, of course, if this was a real attack in a larger network, you'd have lots of different machines to potentially attack. You'd have to do some reconnaissance beforehand to find out what target you're going for. All right, so 172.16.1.5, that is my client machine. I'm going to add that as a target. So adding it to target 1. Likewise, I'm going to highlight this. This is the host machine, so I'm going to add that to target 2. All right, now that I've got those targeted, I'm going to go to my man-in-the-middle menu. It gives me all kinds of different man-in-the-middle attacks I can do with ettercap. I'm going to choose ARP poisoning, and I'm going to say OK. So I've actually started my poisoning attack. Okay, going against these 2 victims. Let's see if it's taken effect. So I'm going to my host machine. I'm going to reissue the ARP --A command. And now that you'll see the address that used to be 172.16.1.5, that used to be 20.98.59, is now changed. Right? It's changed to the MAC address of the Kali Linux box. Let's go ahead and reissue the ARP command on our client machine, and let's see if we see something similar here. Okay, took a little bit there, but let's go ahead and see. Yeah, we've got the addresses now for the host machine now has the MAC address of the Kali Linux box. All right, so our Kali Linux box is in between the 2 hosts. All right, let's go ahead and do this. Let's go ahead and go back here to our Kali Linux, and we're going to go out to our command prompt. And at this command prompt, we're going to use tshark to capture the traffic that's coming through the Kali Linux machine. So that'll be the traffic that normally leaves the Kali Linux machine, and also the traffic that's coming between the client and the host computer. Now for this, I'm going to go ahead and use the tshark program, and that's the command I'm going to want to do later. I'm going to actually do tcap-w, which stands for write, and I'm going to write a capture file named capture. So tshark -w capture. Okay, so now I'm actually capturing the information. Let's go back here And the client computer has a network drive mapping to our host computer. So here I have my drive Z mapping. I'm going to go ahead and copy this super secret text file, and you can see it showed up here on the desktop, and the super secret graphic file, and it showed up here on the host file. So I copied those over. That's it, nothing more to see there. All right, I'm going to come back here to my Kali Linux machine, and I'm going to stop my attack. So here I'm stopping the man-in-the-middle attack. The attack's been stopped. I'm going to go ahead and I'm done with that ettercap. I'm going to go ahead and do a Control-C to stop the capture. I'm done doing the capture. Now let's go back here to our host machine. We're going to do an ARP space -A. We're going to see if that's changed back. And now you can see it used to be, they both used to end 4B38, but now it's updated its cache. It's gone back to the way it should. Likewise, let's try the same here. And it's too has gone back the way it should. So let's see what we got in those capture files. So what I'm going to do is I'm going to search those capture files and export any objects that were using the SMB protocol. The SMB protocol is the Windows file sharing protocol. All right, so I'm going to do T-shark, gotta spell it right, -R for read. I'm going to read the capture file. I'm going to export objects looking for anything with SMB, and I'm going to write it to a directory named out. So it's going to dump those objects there. So it's gone ahead and dumped those objects. If I do a listing from my current directory, you'll see that I have an out directory. I'm going to go ahead and change to that out directory and do a listing. And here you can see I have a plethora of files. So here I see that I have a secret file. So I'm going to go ahead and cat my secret.txt file. And press enter. So it captured that text file. And here it is. That was the contents of that text file. So if we have any doubt, we can come back here, pop open the secret text file, and there you have it. Likewise, I can copy that graphic file to my Kali home directory where I can better view it. And there it is, my super secret art file. So as you can see, with some readily available tools, I was able to exploit the ARP process and literally grab files from a network capture. Kind of scary. So what can we do? How can we protect our networks from ARP attacks? Well, there's a couple things we can do. The first one is we can create static ARP tables. Let's be honest though, it is possible to statically map all MAC addresses in a network to their rightful IP addresses. However, this is not a very good suggestion. This would be great for preventing ARP poisoning, but it adds a tremendous administrative burden. It's just not really realistic or feasible. But on a smaller network, it is an option. Probably the better option is to have better quality equipment. Implementing switch security. specifically the use of dynamic ARP inspection, or DAI. Those features evaluate the validity of each ARP message and drop packets that appear to be suspicious or malicious. It used to be only managed switches or higher end switches had dynamic ARP inspection, but that functionality is coming down to lower range equipment as well. It is definitely something that you would want to enable on your network. Then of course there's physical security. Properly controlling physical access to your place of business can help mitigate ARP poisoning and spoofing attacks. Remember, ARP messages are not routed beyond the boundaries of a local area network. So would-be attackers must be in the physical proximity to the victim, or the victim's network, I should say, or already have control of a machine on the network. Now, that's great for bounded communications across wires. Not as easy to do when we're talking about communications such as wireless, which, as we know, wireless doesn't stop at the walls. The signal will travel as far as it can. Another thing that we can do to mitigate is network isolation. A well-segmented network may be less susceptible to ARP cache poisoning and spoofing, because remember, it can't go past those local area networks, those segments. So by keeping things divided up, you can make things more secure, or at least minimize the effects of the attack. And then lastly, encryption. Encryption isn't going to stop an ARP spoofing or poisoning attack. However, by using encryption, if they do capture the data, they won't be able to do much with that data unless they also then have to break the encryption as well. Right? So again, the use of encryption can help mitigate those attacks. I hope you enjoyed this video. There's so much more that we can learn and do to protect our networks from these types of man-in-the-middle attacks. This is just one that we're looking at today.